question is asking for an equation of the line tangent to y equals to fx at x equals to 2. So if we want to find the equation of a line, what we do is we need to find this element. We need to find m, we need to find x, we need to find y1. And x1 and y1 is actually just a point. Let's name it as p. x1, y1. How do we find m? M is slope. We differentiate the equation. F prime equals to, we plug the number in. When x equals to 2, we got m equals to 45. So how do we find x1, y1? We have already know that x equals to 2, so we know a point, x1. So what if x equals to 2, how about y1? And y1 would be, we plug x equals to 2 into the original function. 4 times 2 to the 2 cube minus 3 times 2 minus 1, which is is 25. So we know y1, we know x1, we know m. We put these 3 elements into the standard form, we will get 2 times x minus 45 plus 25. This will give us the answer C. Y equals to 45x minus 65. Alright, let's move on. The second question is very simple. The question is asking for the derivative, the first derivative function of the original function, cosine x. This is a rule. So like just reviewing, sine x, the prime sine x equals to cosine x. Prime cosine x equals to minus sine x. Also, there's some stuff at the, in the textbook that might be very useful to memorize. On page, let's see, page. All right, page 214. 214. These are equations. So sine prime sine x equals to cosine x. Cosine x equals to minus sine x. We also know prime tangent x equals to secant square x. And for the secant is minus secant x times cotangent x. How about second? This is the derivative of it. The last one, cotangent. Right, so how do we memorize this? So sine and cosine is very easy to memorize. This is a positive sign here. So for cosecant, we can see C, C, C. So it's C minus C, C itself, but with a minus sign and cotangent. Well, we have to memorize these equations for the test. Yeah. Alright, this is question number 2. we have equation x times 1x. The minimum value attained by y equals the minimum value. So if we have equation, there is a minimum value here. What can we tell? The slope of the minimum is 0. So we find the derivative function of this equation using product rule. So let's review the product rule again. F, let's see, A times B. F equals to this. The prime would be A prime B plus B prime A. So here we go. The prime of x is 1. Prime of ln x equals to 1 over x. This is also something you have to memorize. So 1 over x plus ln x. Sorry, excuse me. Because x times 1 over x plus ln x times 1. So cross multiply. So what you get is 1 plus ln x. Plus, no. And 4, let's see. What can we tell right now is it's asking for the minimum. We know the derivative when the slope is 0, that is the local minimum or local maximum. So if this equation equals to 0, and applying a value of x will make the original function have a minimum value. So let's solve for x. Ln x equals to minus 1. X equals to e to the power of minus 1. So it's 1 over e. And the answer is C. Alright, let's move on. 5. 5 is a good problem. So first step is always find the g prime. So here you have to be careful. Low high low. If I open this, this will give me how do I extend it? Alright, never mind. So as we see here, x 4 over x plus 2 square. 4 over, when x equals to 2, so it's 2 plus 2 square equals to 4 over 16, which is 1 over 4. That's the answer. And 1 over 4 is choice C. Alright. Next page. 6. Okay, so now we have a term called this. This is, so for integral a to b, if we have a function fx. The approximation of this is b minus a times fa plus fb over b or 2, excuse me, or 2. Yeah. So we have a graph. This is b, this is a. b minus a, which is the value of this. And here is fa, here is fb. We're doing is just like calculating the, like, this is really just approximation of the integral. This I don't know whether this will appear in the midterm test or not. You have to ask Mr. Pellet, but here you go. The way we just calculate the problem. Now the question is asking for fx, so it's 5 minus 1 times 3 plus 1 or 2, and 3 and 1 just like you find the graph when a equals to 3, when x equals to 3, it will give you when x equals to 1, that will give you a value of 1. This is when x equals to 1. This is when x equals to 5. Because 5 and 1. If we just average, it's 4 times 4 times 2 is 3 equals to 8. So the answer is B. Next problem. 7. Open your book to page 300. The sum rule for integral f a to the b f x plus or minus gx equals to this fx plus integral a to b gx. This is called the sum rule, or minus rule, sum or difference rule. It's very similar to the limits. Okay. So have you memorized it? Okay. Let's see, how do we do this? According to the question, this equals to 6. This equals to 6. So 6 plus, how do we calculate this? What this means is 4, there's 2. And here's a line 3, y equals to 3. That is the function gx actually. So write y equals to 3. So it's a line. Now how do we do this? It's 4 minus 2 times 3. So here is 3. And here is 2 times 3 equals to 6. 6 plus 6 equals to 12. And 6 is here. This 6. And this 6 is because of the question Kip has already given us. So 12 is the answer, which is D. Next one. 8. This is a very hard problem, at least to me. We are trying to find, the question is asking us to find this. Using the chain rule, we know f prime g x times g prime x. But we don't know f prime, we don't know g prime. We have to calculate this two now. This one is easy to spell, or x, but this one is kind of complicated because we have to use the chain rule again. And how do we do this? It's like we the outer function is e to the x, and the inner function is 2x. So we put e2x times the derivative of this, which is 2, will give me 2 times e2x. This is f prime. F prime is this. That is J prime. J prime. Oh, looks disgusting. Okay, here we go. That's J prime. So we put everything in. Let's see. Let's see how do we do this. All right. 2 times e to 2x. So here we plug gx into the x, ln x, times g prime. G prime is 1 over x. And the number 8, look at your question again. X equals to e. X equals to e. So 2 times e to ln e 1 over e equals to 2 times. Oh, excuse me. Oh no, it's alright. I didn't make a mistake. I thought I did. Ln x. Now it's ln e. So what is ln e? Ln e equals to 1 because e to 1 is e. So this will be 2 times e squared times 1 over e. So also we can write this as 2 times e times 1 over e. And e times 1 over e is 1. So we'll get 2e. And what is the answer? 2 is C. Alright. Love question 9. This is very simple. Again, what is prime? Slope. Prime equals to slope. The derivative equals to slope. Slope. So, well, my way to do this is because x equals to 2 is a transition point. When x is bigger than 2, then the function is just x minus 5. Since the absolute value has no function, then when the inside, when x minus 2 is bigger than 0, the absolute value has no effect to the hx. Therefore, when x equals to 5, because 5 is bigger than 2, so the slope of this function is just 1. So the question is B. But if you don't really understand, I can draw a graph for you. The way you draw the graph is this. So we do x minus 2 first. How about the x minus 2? So when x equals to 0 is minus 2. When x equals to 2 is 0. And then because we put an absolute value here, therefore, no matter for all value of x, y always is bigger than y is always bigger than 0. Here we go. That's the original one. Okay, and then minus 3. Minus 3 means we shift the graph 3 units down. So what we will get is this. 1, 2, 3. Here we go. So the slope when x equals to 5, here is 2, 2. 2 is still the transition point. X equals to 2. So here, like when x equals to 5, of course the slope is 1. Let's see, we're talking about 20 minutes. 10. tricky, very tricky. We need to fill the blank. X, oh, excuse me, still lost. We need to fill the blank. X can't equal to 0, because when x equals to 0, this is 0 over 0 is undeterminate, undefined, whatever you call it. Doesn't exist. So when x equals to 1, that is k. So we need to figure out what is the exactly point, I mean the value of y when x equals to 1, which means we need to find the blank. It's like we need to find the blank. We need to find this point. The way we do it is using knowledge of limit. Well, actually, it's not using the knowledge of limit, but it's more like using the knowledge of algebra. This is the same thing you did when you were in algebra 1 or 2. So I just multiplied the original function by 1. A over a, square root of 3 plus 3 plus square root of 3x plus 3 over square root of x plus 3 plus square root of 3x plus 3. So, yeah. The reason I do it is because a minus b times a plus b equals to a squared minus b squared. And a squared, since there is a square root there, a square root of square is just like disappear. Square root will evaporate once we put a square there. The square root will disappear once we put a square there. Okay. Anyway. Oh, no. Alright, so alright, simplify it. This will give us minus 2x plus 2 over minus 2. We factor minus 2 out. Since here is positive 2, so here is a minus sign here. Therefore, we cancel it. It's minus 2 over the square root of x plus 3 plus the square root of 3x plus 1. And the question is asking for when x equals to 1, when x equals to 1, square root of 1 plus 3 is 2, and 2 plus 2 equals to 4. So this equals to 2, this equals to 2. So minus 2 over 4 equals to minus 1 over 2. It's minus 0.5, which is the answer D. The answer D. Go back. Next page. Alright, so part 2, multiple choice still. But in this section you can use your calculator, which means I don't have the calculator software in my computer. So I will just skip the calculating part. You can do it by yourself. 11, question 11. So it gives us an empty tank at a rate of RT equals to 20 times E. I write this down. RT equals to 20 times E to the power of 0.02 T. Gallons per minute. Approximately how many gallons of water have been pumped into the tank in the first 5 minutes? Integral RT dt. This first 5 minutes is 0 to 5. So give you an answer 105. That's the answer. The answer is D. Next question. A tangent line drawn to the graph of y equals to 4x over 1 plus x cubed at a point 1, 2. Okay, so forms a straight triangle with a coordinate axis. The area of the triangles. This is just a fancy way to explain it, to positively, but positive. Okay, so yeah, you just plug this equation into a calculator using the math. Press math 9 infinite. I don't know whether I pronounce it right or wrong, but you tap y1 using letters x 1, 2, give you an answer. Number D, 4.5. Hope you get it right. Alright, next page. 13. Alright, 13 and 14 are hard because I have to draw the graph. Okay. 1, 2, 3, 4 is 0.5. And choice A, F1. Positive. I mean, oh, no. Sorry. Such a terrible. Well, 0.1. This is positive. But the derivative of 3, f prime 3, which is the slope. Oh, excuse me, I made a mistake. I'll draw the whole graph again. So the first choice, f1 bigger than f prime 3 is correct. The reason is f1 is a positive value, and prime 3 is a negative value. So it's right. Number 2. The integral 1 to 2 fx dx is bigger than the derivative of 3.5. 3.5 here is 0. And the area integral is area 1 to 2 here. Where we go? It's not 0. It's bigger than 0. So it's right. Third. The derivative of down 0.2, the instantaneous slope. I mean, anyway, it's just slope at 0.2. The limit when h goes to 2 of f2 plus h minus f2 over h. That is just finding the slope in here. But the second one is the approximation. 2.5. think that. So this value is this one is more steep than that one, which makes the third choice right. So the answer is E. Keep going. 14. I hate graphing. Alright, let's try something fancy here. Wow. Alright. Number 1. At the point where x equals to minus 3, x equals to minus 1, 2, 3. Alright, I confess, I made a mistake. At the points where x equals to minus 3 and x equals to 2 are the horizontal tangent. Be careful, be careful. This graph is f prime, and it is asking question for f, for the original function. So let's see. When x equals to minus 3, that's a critical point. Of course, it has a horizontal tangent line there. But when x equals to 2, the original graph is still increasing because it has a positive value there. Since this graph is prime, it's f prime. So the original function is still increasing, has a positive slope. So therefore, it doesn't have a horizontal tangent line, but a linear tangent line instead. So the second one, this one is false and true. At the point where x equals to 1, there is a relative minimum point. 2 is right because x equals to 1. There is it's negative, 0, positive. Negative, 0, positive, so it's going down, 0, positive. Local minimum. 2 is correct. 3. At the point where x equals to minus 3, there is an inflection point. Well, yeah, of course, why not? Because it's this is going at x equals to 3, so this part. It's increasing 0, I mean local minimum, and then going down. This is for the f prime, so the original function would be, increase would be concave up, concave down, point of inflection. So yeah, the answer is D. Alright, here I want to make a conclusion for revealing like a very confusing concept. This, Mr. Peller did this before. I want to do this again. So when the second derivative is bigger than 0, the first derivative function is increasing. When this is 0, we have a local maximum or local min. When f2 prime is smaller than 0, we know it's decreasing. When f prime is increasing, we know the original function is concave up. When the function is decreasing, we know the original function is concave down. And when f prime prime goes to 0, there is a point of inflection. This graph is very important. Very, very important. If you, yeah, at least to me, it's very useful to memorize it. All right, 15. S equals to 4 pi r squared. F prime would be 4 pi 2 r, which is 8 pi r. 8 pi r. And according to question, we know the surface area is growing at 48 square meters per second. So this value is 48. 48 equals to 8 pi r. Apologize. This when we find the differentiate of this original function, we have to do both sides. You see, this is a very common mistake. So when you do the left side, you differentiate the left side. You have to differentiate the right side too. So here, also I differentiate the r. I forgot to put dr dt there, which would cause a tremendous effort to correct the loss of time. Okay, so still we don't know r. So how do we figure out r? We know when the volume equals to 32 pi over 3. This is a volume, and we know the function for this for the volume is v equals to 4 over 3 pi r cubed. Let's do this. Yeah. So 32 pi over 3 equals to 4 over 3 times pi r cubed. Cancel. 8 pi equals to pi r cubed. Cancel. 8 equals to r cubed. R equals to 3. Oh, thank you. R equals to 2. Because r equals to 2, therefore we plug the value back into the function here. So 48 equals to 8 times pi times 2 times dr dt. And the dr dt would be 3 over pi, which is the answer C. Alright. Question part 3, question 16. A. Using the variable information, make lower and upper estimates for the total amount of water that leaks out during the 10 hours. So left and right. Well, the lower estimation and upper estimation is actually just left and right. So left and right. For the left one, you you add all of them together. Which give you 374, if I didn't calculate wrong. And then the right, which is the upper limit, will give you this. 274. This is the answer for question 1. In question 2, in this example, the flowing rate has been measured every 2 hours. So, how often would you need to measure the flow rate so that your air, the answer is right, but I forgot to put the 2 there. So here you create an equation. The absolute value of FB minus FA times B minus A over N equals to this. So we plug the number in. This one is 60 because it's 71 minus 11 is F. Okay, I will write. F0 of 10 minus F0. This will give us a value of 60. And 60 times 10 over N has to be smaller than 10 gallons. So 600 over N smaller than what? 10. So N has to be bigger than 60. You know, to be that accurate. Suppose you are now informed that the rate of flows was exactly RT equals to 71 times 0.840 to the power of T. So here we go. We are using integral to calculate the rate of change. So the integral of the rate of change is the area, which is the amount of water that it flows during this period of time. So you plug this function, you put this function into your y1, your calculator, and then using the math 9 to calculate the integral, which is 336. That's the answer. Excuse me. 17. Last 3 questions. 17 is actually a very simple question once you know what the question is asking for. So number 1 is how many kilometers away from A is the car at time t equal to 6? So the graph is velocity time graph. And the question is asking you for time position graph, which means you have to find the integral in order to do this problem. So I'm going to draw the graph here. 6, 7, 8. Add 2 is the next thing. Let's keep going 1. Four is decreasing. 5 is decreasing. 6, 4. 7, and 8. Alright, so 0 to 4. The question is asking for the kilometers away from A the car at the time equals to 6. So we need to analyze this velocity time graph first. So the car is moving positive, stop, then going back. No, that's not right. Here's the motion. It's increasing. The velocity is increasing, and then it stop. It stop, a constant. That's a constant speed. And then the acceleration is decreasing, moving slowly, and then it stop. And it's moving in the opposite direction and time equals to 4. And it's accelerating. And then when t equals to 5, it starts to decreasing, acceleration reaching 0. Then stop. And then stop there for 1 second. And then start to moving again, accelerating. So how do we know the distance here is the area above x-axis is positive, the area below x-axis is minus. So we just count. We count the grid here. Here is 1, here is 4, and the height is 2. So 1 plus 4 times 2 divided by 2 equals to 5. This is how we calculate something like this. This is A, this is B, this is H. So S equals to A plus B times H times half. Very useful formula if you don't want to just do approximation. And we get 5 here, there. And here triangle area is 0, here is 2. So 0 plus 2 times height. Height is 2, over 2, which is 2. But remember, this is minus 2 because this is below 0, below x-axis. We add them together, 5 plus minus 2 equals to 3. That's the answer for A. Alright, so how about question B? At what time does the car change direction? Explain briefly. What time does the car change direction? So we have to think about this. Like when did it change direction? It's only when the velocity changing direction change from positive to negative, or change from the negative to the positive. So when t equals to 4, look at your graph again. We see the velocity is changing from positive direction to negative direction. And from 6 to 7, it's hard to tell, but we know the car is decelerating at 6 and then stop there for 1 second and then start to move. So when did it change direction? It's not from 6, because from 6 to 7 it is stopped there. It's stopping there. It's waiting. So actually when t equals to 7, the car changed direction. Okay. So C, at the axis provided, sketch a graph of acceleration of the cars. The graph would be something like this. 2, 1, 2. Okay, we'll draw this in. One unit, 2 unit. 1 unit. 1 unit, 2 unit. 1 unit, 2 unit. 1 unit, 1 unit. This is a graph. Next page. 18. The last problem, if you don't count bonus question. So this is a tricky question actually. It's harder than bonus even. because you have to think really hard about each variables, each number. Let's go here. So the first question A, find the values of P and Q so that F minus 1 equals to minus 8 and F prime minus 1 equals to 12. Let's see. When we plug the value of x equals to minus 1 into the original function, so 1 plus P plus Q equals to minus 8. We name it function, let's use Greek letter, alpha. So secondly, we calculate the derivative of the original function, which will give us 3 times x cubed minus 2p times x plus q. And when x equals to minus 1, which is 3 plus, 3 minus 2p plus q. This equals to 12. We call this beta. And then we simplify these two equations. P plus Q equals to minus 9. Q equals to minus 9. And the reason is because, I made a mistake at the beginning part. Because the first is f equals, when f minus 1 equals to minus 8, I plug x equals to 1 instead of minus 1. So we have to fix the problem. This would be minus. I will start it again. Another color. So we plug the value minus 1 to the function. Minus 1 plus P plus minus Q equals to minus 7. This is the first equation. We call it alpha. And then we find the derivative of the original function, which is 3x squared plus 2px plus q. And we put the number x equals to minus 1 into the function. We will get 3 minus 2p plus q equals to 9. We call this beta. Now extend this page. P minus q equals to minus 7. And minus 2p plus q will give us a value of 9. I'm making a mistake. And we adding these two equations together, we will get minus p equals to 2. So p equals to minus 2, and q equals to 5. So the answer for the first question is p equals to -2, q equals to 5. B. Find the value of p so that the graph of f changes concavity at x equals to 2. So when does a function change concavities? When the second derivative of original function is equal to 0. So f prime prime equals to 0, which is 3x squared plus 2px plus q. This is f prime, so we have to differentiate this again. We will get 6x plus 2p equals to 0. And when x equals to 2, 12 plus 2p equals to 0. So 2p equals to -12. P equals to -6. There's the answer for number B. C. Under what conditions on P and Q will the graph of f be increasing everywhere? When does the graph increase? It increases when f prime is bigger than 0. In other words, 3x squared plus 2px plus q is bigger than 0. That is when the graph of f is increasing. So, yeah. If you want to solve this, you can plug into the equation. And I did that in calculator, so I'm not going to do this right now. Let's move to the last question. The brownie question. Given the curve y cubed x equals to x squared plus y minus 7, find the equation of the tangent line to this curve at the point 3, 1. The way to do it is we differentiate both sides. We will get 3y times dy dx times x plus y squared. This is using product rule equals to 2x power rule plus dy dx, y turn into 1, but still we have to differentiate dy dx. And minus 7 turn to 0. So we put dy dx into one side, dy dx times 3y squared times x minus 1 equals to 2x minus x cubed. So dy dx equals to 2x minus y squared over 3y squared x minus 1. And we plug the number 3 and 1 into the equation. We will get dy or dx equals to 2 times 3 minus 1 squared, or 3 times 1 squared times 3 minus 1. 6 minus 1 over 3 times 3 minus 1 will give us a value of 5 over 8. And 1 over 8 is 0.125. So times 5 would be 0.625. If I didn't calculate it wrong. But 5 over 8 is good. So, yeah, that's all. That's all for the reviewing package. So if you have really carefully finished all these problems, I think you will probably be fine in the midterm.